Yes. Hello friends, welcome to the session. Continuation of chapter 4, that is measurement of voltage and current. In the last session I discussed about what exactly PMMC voltmeter, that is DC voltmeter concept. Then how to define the sensitivity of DC voltmeter. Okay. In this session we'll start with one concept with respect to PMMC voltmeter, that is loading effect due to voltmeter connection. Yes, listen please. What is the loading effect due to voltmeter connection? Yes. Okay. Loading effect due to voltmeter connection. No doubt at all, every meter will offer the loading effect, but mainly here I am discussing what the loading effect due to voltmeter connection. Okay. Let us consider first one theoretical circuit. Let Vs is the supply voltage. Okay. Rs is the source resistance. S. RL is the load resistance. IL is the load current. S. VL is the load voltage. Okay. Then theoretically, how to calculate this voltage across the load by using this circuit, you tell me. Then what is VL equal to? Apply voltage divider rule. What we get? Vs into RL by S. RL plus RS. RL plus RS. Then whatever the voltage is measured by using this circuit, this is the true value of load voltage. Why it is a true value of load voltage means we are measured exactly voltage across the RL resistance, load resistance. That's why it is nothing but a true value of load voltage. But practically what you can do to measure the voltage across the load, we can use one voltmeter. Na? I think all are conducted experiments in the laboratory. In that laboratory, if you want to measure the voltage across the load, directly can you apply voltage divider rule? No, we can connect one voltmeter. That means this is theoretical case, but practically yes, to measure the voltage across the load, voltage across the load, okay, a voltmeter is connected. Yes, a voltmeter is connected. To measure the voltage across the load, a voltmeter is connected. Now if voltmeter is connected, what happens? That I want to explain. Let the same circuit, Vs is the supply voltage, yes, Rs is the source resistance, then RL is the load resistance, then IL is the load current. To measure the voltage across the load, we are connecting one voltmeter. Let this voltage is VL. This voltage measured by this voltmeter is VL. But point to remember, whenever voltmeter is connected, this voltmeter is also having some input resistance, but the input resistance of voltmeter is not neglected. This is very high input resistance. Because of the input resistance of voltmeter, this resistance is in series with meter. Now this resistance will come in parallel with RL. That means whenever voltmeter is connected, because of input resistance of voltmeter, in this circuit, the total resistance is not RL. The effective value of resistance is RL effective, that equal to RL in parallel with RV. Understand? Whenever voltmeter is connected, because of input resistance of voltmeter, now the resistance in this circuit will be changes to RL effective. That RL effective is RL in parallel with RV. Therefore, RL effective equal to RL into RV by RL plus RV. This is effective value of load resistance. Now listen please. Now how we can define, now what is the voltage measured by this voltmeter? Now voltage measured by this voltmeter VL equal to Vs into RL effective by Rs plus RL effective. Yes. Then whatever the voltage measured by using this, it is not a true value, it is a measured value. Then VL measured equal to Vs into RL effective by Rs plus RL effective. Understood? Listen please. It is not a true value, it is a measured value. Why? This voltmeter is not exactly measuring RL. It is measuring RL effective. Now this is nothing but a loading effect. Then how to define loading effect, you tell me? That is, whenever voltmeter is connected, because of input resistance of voltmeter, the actual load conditions are changes. Once the actual load conditions are changes, measured value is deviated from the true value. This effect is called loading effect. And whenever measured value is deviated from the true value, there is some error is introduced in the measurement. That error is nothing but a loading error. Okay. This what exactly loading error? I told now in the discussion of instrumental error, that is loading error is one of the example of instrumental error. That loading error because of instrument only, because of meter only, that's why it is the example of instrumental error. That is, if voltmeter is connected, what is the loading effect? You write down this one. If voltmeter is connected, due to input resistance of voltmeter, actual load conditions are changes. Actual load conditions are changes. Measured value deviated from the true value. Measured value deviated from true value. It is called loading effect. Okay. Loading effect. Yes. And error introduced in the measurement. Is called loading error. Yes, is called loading error. And error introduced in the measurement is called loading error. Okay. Now, how to define percentage loading error? Then you write a percentage loading error equal to, but before that, one point to remember. Sorry. Due to loading effect, due to loading effect, always due to loading effect, always for the condition measured value less than the true value, except this measured value less than the true value. Okay, because of parallel combination, the resistance will reduce, the voltage measured is also reduced. That's why due to loading effect, always measured value less than the true value. Then how to define percentage loading error equal to? Percentage loading error equal to. Okay, then measured value minus true value by true value into 100. How to define percentage error? Measured value minus true value by true value into 100. Then percentage loading error equal to measured value minus true value by true value into 100. But point to remember, loading error is always positive or negative? Negative. Why? Because measured value less than the true value. That is, loading error is always negative. Loading error is always negative. But point to remember, loading error cannot be eliminated completely, but it can be reduced. Why it cannot be eliminated completely? Yes, practically, if you are measuring the voltage means compulsory you can use one voltmeter. Once we are using voltmeter means it compulsory offers some resistance. Because of resistance of voltmeter, actual load conditions will be changes. Then measured value deviated from the true value. That's why loading error cannot be eliminated completely, but it can be reduced. Yes, loading error. Yes, loading error cannot be eliminated completely. Cannot be eliminated completely. But it can be reduced. But it can be reduced. Then how to reduce the loading error? That I want to explain. How to reduce the loading error. For example, let RV equal to infinity. That means we are designing the voltmeter with infinite resistance. This is ideal case I am explaining. Ideally I am explaining. Then I will apply this concept for practically. Okay. Ideally infinity means practically high. Ideally 0 means practically you take low. That means we are designing the voltmeter with infinite resistance. Practically it is not possible. But if RV equal to infinity means what is RL effective? Yes, RL into infinity by RL plus infinity. Then what we can get? RL into infinity by infinity. But infinity by infinity is not defined, but it is the case is ideal. Then it is RL effective equal to RL. If RL effective equal to RL, then what is VL measured we can get? VL measured equal to Vs into RL by Rs plus RL. Is correct? You substitute RL effective is RL, then it is equal to VL true. Then what is error? 0. That means if you select the voltmeter with infinite resistance, then we can get the error equal to 0. But practically it is not possible to design the voltmeter with infinite resistance. But if you connect infinite resistance of voltmeter, then error becomes 0. Loading error becomes 0. That's the reason why infinite resistance is not possible. That's why you cannot make the error is 0. But we can reduce. If you design the voltmeter with infinite resistance, we are making the error is 0. But infinity is not possible. We can design the voltmeter with high input resistance. Once we can design the voltmeter with high input resistance, then what the loading error will be reduced. It will not 0, it will reduce. Therefore, by designing the voltmeter with by designing the voltmeter with high input resistance, or by using high input resistance voltmeter. By using high input resistance voltmeter, yes, loading effect is reduced. Loading effect is reduced. Then how to select that input resistance of voltmeter? In the measurement of load resistance, in the measurement of voltage across the load resistance, that you will see. Concentrate, quick note down. Yes. Listen please. How to select this input resistance? One observation here, to reduce the loading effect, we must design the voltmeter with high input resistance. Okay, that is observation. For example, listen please. This over? Okay. If you design the voltmeter input resistance is, if you take RV equal to RL, this if you take, if RV equal to RL, we are designing the voltmeter with input resistance of RV equal to RL. If RV equal to RL means what is RL effective, you tell me. RL effective equal to, that is RL in parallel with RV. We are designing the input resistance of voltmeter is equal to load resistance. Input resistance of voltmeter equal to load resistance. If RL is RV equal to RL means RL in parallel with RL. Then what we can get RL effective? RL by 2. Then what is VL measured equal to? Vs into RL by 2 by, that is RS plus RL by 2. RS plus RL by 2. Okay. Then VL. Then what the percentage error you can get? Percentage loading error equal to, how much you can get? VL measured minus VL true by VL true into 100. Yes, you know VL measured, you know VL true, you substitute here, we can get minus 39.9% we can get. If you select RV equal to RL, you know VL true na, that you substitute, VL measured you substitute, we can get minus 39.9% we can get. But it is not acceptable. 39.9% means nearly we are getting minus 40% error. Minus 40% means if any voltmeter is used to measure the 100 volts means it shows the reading of only 60 volts. That is never preferable. That's why this condition is not preferable. Don't select the voltmeter with RV equal to RL. To measure the voltage across 100 ohm resistor, we don't select with 100 ohm resistance voltmeter. If you select like this, it offers 40% error nearly, minus 39.9%. For example, if RV equal to 10 RL, yes, if RV equal to 10 RL, we are selecting the voltmeter with input resistance of 10 RL. If RV equal to 10 RL means what is RL effective? RL in parallel with RV, that is 10 RL. That is 10 RL. That is what you can get, 10 RL into RL by 11 RL. Then what you can get, that is 10 by 11 RL. Then what is VL measured equal to? Vs into 10 by 11 RL by RL effective 10 by 11 RL plus RS. Then we calculate percentage loading error. We get percentage loading error equal to S is VL measured minus VL true by VL true into 100. Then we can get nearly equal to minus 6% we can get. Minus 5.34 or 45 like that you can get, nearly equal to minus 6% we can get. Minus 6% error means 94% accuracy. 94% accuracy you can get. Then it is acceptable. 94% accuracy means acceptable. No doubt at all. For example, if similarly, if you select, if RV equal to 100 RL, if RV equal to 100 RL you can select, then you can get error is nearly equal to minus 2% we can get. That is 98% accuracy we can get. That conditions you substitute, then you solve. But designing the voltmeter with input resistance of 100, that is selecting the voltmeter with input resistance of 100 RL is not practicable. That's why the minimum input resistance we can select 10 RL. No need to make 100 RL. The minimum input you select 10 RL. Therefore, to reduce the loading effect, then how we can select the input resistance of voltmeter? To reduce the loading effect. Therefore, to reduce loading effect, practically RV must be greater than or equal to 10 RL. RV must be greater than or equal to 10 RL. Then what is the minimum input resistance of voltmeter you select? Therefore, RV minima equal to 10 RL you can select. No need to make 100 RL. But if you select, no doubt at all, we can get the minimum error. But this is enough. Minimum is 10 RL you can select, but below this don't select, above this. But this is the not acceptable case, RV equal to RL. That means to measure the voltage across 10 ohm resistor, you select a voltmeter with minimum input resistance of 100 ohms. That's the meaning. This is to reduce the loading effect, the minimum input resistance of voltmeter equal to 10 RL. Then again, sir, I will select 20 RL, 30, like that you select, no problem. Again, error will be reduced. If you select like this, we can get nearly equal to minus 5.5%, minus 5.6%. That's nearly equal. This is exact value, nearly value, 6% error you can get. Understood? Like this, select the voltmeters to measure the voltage across the load in order to reduce the loading effect. That means, what's the final observation here? To reduce the loading effect, we must select the voltmeter with high input resistance. Sir, what is the practical significance? By selecting the voltmeter with high input resistance, how the error is reducing? Reason is very simple. We know that to measure the voltage across the load, what we are doing? We are connecting the one voltmeter. If you select the voltmeter with very less input resistance, then total current is passing through voltmeter. Then the current passing through the load is very less. Then actual voltage will not build up. Once the actual voltage will not build up, then it cannot measure the actual voltage. That's the problem. That's the reason why you select the voltmeter with high input resistance. Once we can select the voltmeter with high input resistance, then what the current taken by the voltmeter will be reduced. Once the current taken by the voltmeter is reduced means, then most of the current is passing through the load. Then actual load will pass through the load, then actual voltage will develop, that voltage is measured by the voltmeter. This is the reason. That's the reason why this practical significance is, you design the voltmeter with high input resistance, then the current taken by the voltmeter will be reduced, then it measures the exact value. If the current taken by the voltmeter is reduced, what is the power loss? Reduced. Once the power loss is reduced, then it measures the actual value. Power consumption is less means, whatever the input we are giving, that exact input that will be displayed. Understood? That means, generally we can give the statement like this. The instruments with less power consumption will offer the instruments with less power consumption will offer less loading effect. Understood? See, that observation I want to give. But to reduce loading effect, this is the conditions. Let's concentrate. Yeah, one observation here. Listen, please. If RV is increases, the input, if the input we are designing the voltmeter, we are selecting the voltmeter with high input resistance, then what is the loading effect? Loading effect is reduced. That is, a voltmeter with a high input resistance offers less loading effect. One more observation. If RV is increases, what is the IV? Reduces. Then what is the loading effect? Reduces. That is a voltmeter with less power consumption. A voltmeter with less power consumption. Less power consumption offers less loading effect. S offers less loading effect. A voltmeter with less power consumption offers less loading effect. One more observation. If RV is increases, what the sensitivity is also increases. What the loading effect? That is loading error reduces. Loading effect is reduced. That is, a voltmeter with high sensitivity will offer less loading effect. That is, a voltmeter with high sensitivity. A voltmeter with high sensitivity offers less loading effect. Less loading effect. A voltmeter with a high input resistance, high sensitivity offers less loading effect. Clear? Understand? Concentrate. Every point is important. Okay, this about what is the loading effect due to voltmeter connection. In order to reduce the loading effect due to voltmeter connection, how to select the voltmeter? You must select the voltmeter with high input resistance. The condition is RV must be greater than or equal to 10 RL. Then the minimum value of input resistance equal to 10 RL. Okay, note down quick. Yes, but point to remember, not only voltmeter, every meter will offer the loading effect. Every meter will offer the loading effect. For example, see, let us consider one circuit, one theoretical circuit. Let the voltage is V. For example, voltage is V. Let the resistance offered by the sources, let us assume that R1. Or voltage is V. Let neglect the source resistance. Let the load resistance is RL. Okay. Then let this current is I. Then what is I equal to? V by RL. V by RL. Or otherwise, let the resistance is, some resistance is R1. Let this current is I1. Let these terminals are short circuited. Let this current is I1. Then what is I1 equal to? V by R1. But practically to measure this current, what we can do? We can connect one voltmeter. Sorry, we can connect one ammeter. Let this is R1. Then we are connecting one ammeter. Ammeter will offer some resistance, na? Let that is Rm. Then this is V. Let this current equal to measured current. Then what is Im equal to V by R1 plus Rm. This is true value. This is measured value. This measured value is not equal to true value. Then there is some error is introduced in the measurement. This is because of insertion of ammeter. Due to insertion of ammeter also we can get some error. Okay, that is also nothing but loading error. That's why every meter will offer loading effect. Voltmeter will offer loading effect. Even ammeter is also offers the loading effect. Clear? But point to remember, to make the error due to ammeter is 0, Rm must be 0. If Rm equal to 0, then measured value. If the meter resistance equal to 0, let this is ammeter. If the meter resistance equal to 0, then measured value equal to true value, no? Measured value equal to true value. Okay. If the meter resistance is 0, that means if the input resistance of voltmeter is infinity, then measured value equal to true value. But here, if the meter resistance is 0, measured value equal to true value. See the observation. That means for all parallel connected meters, to reduce the loading effect, it must have high input resistance. For all series connected meters, to reduce the loading effect, it must have less input resistance. This is the difference. Every meter, this voltmeter will offer loading effect, CRO will offer loading effect, wattmeter will offer loading effect, ammeter also will offer loading effect. But conclusion is here, for parallel connected meters must have high input resistance to reduce the loading effect. Series connected meters must have less input resistance to reduce the loading effect. Therefore, you write as a note. To reduce the loading effect due to parallel connected meters. To reduce the loading effect due to parallel connected meters. Yes, it must have high input resistance. This is one observation. Then to reduce the loading effect due to series connected meters. Yes, to reduce the loading effect due to series connected meters. It must have less input resistance. Okay, this about what exactly loading effect due to mainly voltmeter connection. So to understand this concept, I'm giving one small example here that you will see in detail in the classroom workbook also. Based on this concept, I will solve some problems. But here to understand this concept, I'm giving one example. See, for example, let us consider this is 400 kilo ohms and this is example I am giving 200 kilo ohms. Okay, and the supply voltage is 100 volts. To measure the voltage across this, we are using one voltmeter. It is a 0 to 100 volts voltmeter. The sensitivity of this voltmeter is 2 kilo ohm per volt. Okay. Now, first, how we can get the true value? Tell me how we can get the true value without voltmeter or with voltmeter? Yes, without voltmeter we can get the true value. Without voltmeter. First, you solve this circuit without voltmeter. Then without voltmeter means this is 400 kilo ohms, this is 400 kilo ohms, and this is 200 kilo ohms. Across this we are measuring the voltage, and this is 100 volts. Okay. Now what is the voltage across 200 kilo ohms? VL equal to 200 into 100 by voltage divider rule. 200 plus 400. How much we can get? 33.33 volts we can get. This is the true value because we are not considering the voltmeter. Now when we can get the measured value? With voltmeter. With voltmeter we can get measured value. With voltmeter you do this value with voltmeter. Can do this with voltmeter. If you take with voltmeter means this is 400 kilo ohms and this is 200 kilo ohms. To measure, this is 100 volts. To measure the voltage across the load we are using voltmeter. Yes, it is a 0 to 100 volts voltmeter, 2 kilo ohm per volt. But directly input resistance is not given, sensitivity is given. How to calculate? One way to calculate SV equal to RV by V. Then what is RV equal to SV into V? Then how much we can get? 200 kilo ohms. Or you also calculate like this. What the sensitivity indicates? 1 volt equal to 2 kilo ohms. But always input resistance is calculated for full scale value. 100 volts equal to 200 kilo ohms. This also input resistance. Like this also you can do. Any method you follow. Okay. Then the input resistance is 200 kilo ohms. Load is also 200 kilo ohms. What is RL effective? RL effective equal to 200 kilo ohms in parallel with 200 kilo ohms. Then how much we can get? 100 kilo ohms. Then what is VL measured? VL measured equal to S. Vs into RL effective by Rs plus RL effective. Then what is Vs? 100. RL effective 100 by 400 plus 100. How much we can get? 20 volts. That means what is VL measured we are getting? 20 volts. What is the VL true we are getting? 30. That's why due to voltmeter connection the measured value is deviated from the true value. Now this effect is called loading effect. Then what is one observation? Measured value less than the true value. Then what is the percentage loading error? Percentage loading error equal to, how to calculate? Yes, percentage loading error equal to measured value minus true value by then true value into 100. Then how much measured value? 20 minus 33.33 by 33.33 into 100. We can substitute, simplify this, we can get minus 39.9% error we can get. See the observation. Why this much of error we are getting? Minus 39.9% S. What is RL? 200 kilo ohms. What is RV also? 200 kilo ohms. Because of RL equal to RV, this error we are getting. Because of RL equal to RV, we are getting minus 39.9% of error. Okay, see the observation. That this is the loading effect. Okay. If you solve the same problem, instead of 200 kilo ohms of input resistance of voltmeter, you take 2000 kilo ohms. You try that one. Instead of 200 kilo ohms, you take 2000 kilo ohms. If you take 2000 kilo ohms, then what is the RL effective will be? Changes. What is the RL effective? This RL effective 200 kilo ohms in parallel with 2000 kilo ohms. This will be changes. Once it is changes means what the measured value also changes. Then once the measured value changes, loading error is also changes. But loading error increases or reduces? Reduces. 2000 kilo ohms RV means what is the condition we are satisfying? RV equal 10 RL we are selecting. If RV equal 10 RL means nearly we can get minus 6% error, that you can prove that. In this problem, in this example that you try by your own, take RV equal to 10 RL, that is means 2000 kilo ohms you take here, then you calculate measured value, No doubt at all. Whatever the measured value you can get, this must be increased. Why error is reducing means measured value tends to the true value. Measured value tends to the true value. Then error will be reduced. Then we can get nearly equal to -6% error. Okay. This about what exactly loading effect due to voltmeter connection. Okay. This is one concept with respect to PMMC voltmeter. Okay. Then two small theory concepts are there and one mathematical calculation is also there with respect to PMMC voltmeter, that is separate concept. In that I want to discuss what is the properties of shunt and series multipliers. We know that in PMMC ammeter we are using which resistance? Shunt resistance. In PMMC voltmeter we are using which resistance? Series resistance. Whatever the shunt and series resistance we are using, then that shunt and series resistances are made with which material? Then what is the properties of materials used for shunt and series multipliers? That I want to discuss. Then I want to discuss one more theory concept, that is nothing but a swamping resistance. What is the purpose of using swamping resistance? Then what is the temperature errors? Then how to calculate temperature errors? These concepts I want to discuss. Okay. In the next session, we will continue with that theory concept. With that, and finally, I will give some conclusion also. What is the special application of PMMC instrument? With that, PMMC concept will be, theory concept will be completed. Okay, will be complete. Okay, this about loading effect due to voltmeter connection. This you concentrate. Thank you.